The Man Who Lost a Month. Act 1. The Surface Record. On July 16, 1962, Michel Siffre removed his watch and descended into the Scarasson abyss in the Alps. He was 23 years old, trained as a geologist, and expected to remain below ground until September 14th. He and several other cavers had found an underground glacier there the previous summer. Siffre first planned to spend about 15 days studying the ice. He extended the stay to 2 months and added another subject to the expedition: his own sense of time. Research on biological rhythms already existed. In 1938, the physiologist Nathaniel Kleitman and a research assistant had spent more than a month in Mammoth Cave in Kentucky while trying to follow an imposed 28-hour schedule. Siffre used a different arrangement. No schedule at all. He would eat when he felt hungry, sleep when he felt tired, and get up when he woke naturally. His camp stood beside the glacier in a cramped section of the cave. The temperature was around freezing, the humidity was extremely high, and his equipment offered little protection. His rubber boots remained wet. He later said that his body temperature fell to 34 degrees Celsius. A lamp gave him enough light to read, write, prepare food, and work, but there was no sunrise, evening, or change in the weather. A telephone connected him to the surface team. The rule was one-sided. Siffre could call when he woke, when he ate, and before he went to sleep. The team recorded the time of every call, but could not tell him the hour or date. They were not allowed to call him first. Each awakening therefore produced 2 entries. Siffre counted another physiological day. The team wrote down a clock time he could not see. He also measured his pulse and performed a short test. He tried to count from 1 to 120 at 1 number per second. The task should have lasted 2 minutes. At one point, it took him 5. Act 2. 42 Awakenings. At the surface, July 17th followed July 16th. Underground, the next unit began only when Siffre woke. His sleep and waking continued to form a rhythm, but it did not remain fixed to the 24-hour day. The interval between his awakenings averaged about 24 hours and 30 minutes. Half an hour is a small error across one day. Repeated without a sunrise to correct it, the error moves breakfast into the afternoon and sleep into the morning. After roughly 2 or 3 weeks, Siffre could be waking at 6 in the evening and going to bed at 6 the next morning. He did not experience this as night work. The sleep record and his sense of duration also began to separate. A cycle slightly longer than 24 hours could move his routine around the clock, but it could not by itself erase several weeks. That larger error appeared in his counting test, his memory, and the way one dark interval joined the next. There were books, geological notes, meals, measurements, and telephone calls. There was also cold, wet clothing, limited movement, and the same small camp after every awakening. Events occurred, but the cave supplied few changes by which one interval could be placed before or after another. An entry later, dated to August 30th, began with Siffre's 42nd awakening. He could not sleep, so he dictated his thoughts in the dark. He wrote, "I really seem to have no idea of the passage of time." He tried to calculate it. He remembered entering on July 16th. He counted 41 completed awakenings, but he did not know how long those waking and sleeping periods had lasted. At some moments, he thought he had spent 42 physiological days underground. At others, he judged that only 27 ordinary days had passed. He averaged his own 2 estimates and settled on approximately August 20th. Above him, it was August 30th. He was 10 days behind the surface calendar. On September 14th, The team told him that the planned 60 days were over. Siffre still believed the date was around August 20th. The estimate he had made more than 2 weeks earlier had hardly advanced. He thought that close to another month remained. His body had not stopped producing rhythms. His pulse, temperature, sleep, waking, hunger, and attention still changed. None of those changes supplied the missing date. The ascent added a physical record. Siffre climbed the first shaft with enough energy to surprise himself. In a narrow, bent passage higher up, his strength failed. He later recalled taking an hour and a half to cross 6 meters, while another caver behind him directed him from one ladder rung to the next. He reached the surface, exhausted, and wore dark glasses against the daylight. The surface log ended on September 14th. His own estimate remained August 20th. Act 3. The Free Running Day. The Scarasson record showed that a daily rhythm could continue without a visible day. In Siffre's case, the sleep-wake cycle ran at about 24.5 hours. It was not proof that every human being carries that exact period. Scarasson had one subject, and the subject had designed the experiment. Cold, isolation, artificial light, poor sleep conditions, inactivity, and the removal of time cues were all present together. Other experiments separated some of those conditions. Siffre organized longer cave stays for volunteers, including Josie Lores, who remained underground for 3 months, and Antoine Seny, who remained for 4. Seny sometimes shifted into a cycle close to 48 hours, roughly 34 to 36 hours awake, followed by 12 to 14 hours of sleep. During one interval, he slept for about 34 hours. The team waited for a sound from his microphone before it knew that he was still alive. The results attracted institutions that worked far from ordinary daylight. Siffre later said that NASA funded mathematical analysis of his first experiment. The French military supported later work on sleep, reaction time, aviation, and long periods of duty. Nuclear submarines and spacecraft both created schedules in which sunrise could no longer be trusted to organize the people inside them. In 1972, Siffre entered Midnight Cave near Del Rio, Texas, for a second-long experiment on himself. He stayed for 205 days. The camp was warmer and better equipped than Scarasson. He had food supplied for the Apollo 16 mission, an exercise bicycle, continuous physiological monitoring, and electrodes for recording sleep. The improved equipment removed the freezing conditions. It did not remove isolation. After about 2 months, Siffre lost much of his motivation, and later described the remaining months as a form of imprisonment. During 2 periods, his schedule stretched toward 48 hours, about 36 hours awake and 12 asleep. The cave experiments were followed by controlled bunker and laboratory studies. Later, isolation protocols kept clocks, calendars, sunlight, and social schedules away from the subjects. While researchers maintained an external record, the subjects could not consult. The rhythm that continued was free running, generated within the body, but no longer corrected each day by signals from outside. Light and darkness are the strongest of those signals. Meals, activity, temperature, stress, and social contact can also help set the time. Ordinary life supplies them repeatedly, often before anyone looks at a clock.